Welcome back to the only podcast where we combine Marvel Rivals and chemistry. Okay? Now, today we're going to be talking about gas laws, everyone's favorite thing. Irrelevant in so many cases. Now, first up is the kinetic molecular theory. Gas particles are in constant motion, and the volume of gas does not matter compared to the volume of the container. Gas particles do not have intermolecular forces, their collisions are always elastic, and the average kinetic energy is proportional to the absolute temperature. Now, it's important to realize that gases, they have low density. Yep, Now, next up is the combined gas law. It's a combination of relationships between pressure and volume and temperature. Very useful. Now, the equation for that would be P1V1 over T1 equals P2V2 over T2, with P1 being the first pressure, V1 the initial volume, and T1 the initial temperature, and then the twos being the final. Next up is the ideal gas law, my personal favorite. PV equals nRT, Puvnert if you're nasty, with R being the ideal gas constant of 0.0821 and N being the moles of gas, and the other variables being the same as I described before. That's my favorite one. Now, Dalton's law, states that the total pressure in the system is equal to the sum of the partial pressures. That's another good one. Pressure 1 plus pressure 2 plus pressure 3 equals the total pressure, and vice versa. Now, balloons are a great example of the ideal gas law because when you blow one up, the volume in moles are increasing, the temperature is staying the same, so is the constant, the ideal gas constant, so we can determine the pressure. Nice, fun, wonderful. And Dalton's law can be shown in climbing to higher elevations. The total atmospheric pressure decreases, therefore causing the partial pressure of oxygen to decrease, making it harder to breathe. An inverse example would be scuba tanks, and because of the compressibility of gases, they can store a lot of gases with a large pressure in a small space. Now that pretty much sums up everything about gas laws that I'm required to talk about. So thank you for listening, and come back next time.